Welcome back to Ox Tools. I'm Tom. So we've got our little bar tacked in here, and what we want to do is we want to locate the center of our bearing bore accurately. There's a bunch of ways we could do that, and we'll talk about some of those in a second. But we're going to do this kind of an old school way because I actually get a lot of questions about it. So let me move the camera a little bit, bring you in a little closer so you can see what's going on. And we'll talk about how we're going to do this. Okay, so what we're doing here is this is just a flame cut bore here, so we have to actually put a much larger bore in here. It's something like on the order of kind of that diameter there. And it's not super critical that this be located, you know, dead nuts accurate, but you know, it's a good opportunity for a demonstration. So what we're going to do is we'll centralize it between these two flats here, and then we'll set it at the theoretical distance that we want it off of this bottom edge here, which is also machined. These are 4 machined surfaces here. And what we've done is we've drilled and tapped, you saw me do that in the last episode, we've drilled and tapped a little 540 hole in that, and I'm going to show you why in just a second. So there's a bunch of ways that we could locate this, and I get a bunch of questions about these little guys here. These are Toolmakers buttons, okay? A lot of guys ask me about these things, and I have a set here, and these are Brown and Sharp Toolmakers buttons, okay? And what these are for locating holes real accurately. They give you this nice precision ground surface to indicate on, so you can locate holes very, very accurately with these. Okay, and it's a real old school technique, and but this is kind of a good example of how we could do that. Okay, and these are precision diameters. They're 400 thousandths in diameter, a little over 10 millimeters, and these 3 are the same length. This one's a little longer. That way you can hook a micrometer on it. But the ends are lapped parallel, real flat too. Now, let's see why these are, how these work here. Well, actually, you can see it there. They're quite a bit loose on the screws. Okay, so the idea is that you rough tap a hole, you know, location-wise, and then you precision locate this cylinder and then lock it down, and then now what we do is we indicate on that, and that puts the axis of the machine spot on, you know, where your measurement's located. Okay, regardless of where that little tapped hole is. That's why that little tapped hole doesn't really make much difference. So what we're going to do, and that's I don't know why in God's creation they tap those 540, but that's, you know, they're all these weird sizes. So I never noticed that. Oh, okay, so it's got a, I never noticed that before. It's got a little tiny counterbore in it that fits that screw, so you can put them on either way. It's kind of free rotation, or you can kind of lock them in. But anyway, let's move on here, and we'll pinch this. So now you can see I can move that around, right? So now what we're going to do, there's a bunch of ways that we can locate this, and we're going to use another tool that I get a lot of questions about, which is a planar gauge. So we're going to use a planar gauge and some space blocks to precision locate that diameter. So I have numbers from here to the center and from here to the center, so we're going to set that up. So let me get that junk, and we'll move the camera a little bit and you guys can see that. Alright, so we got our Toolmakers buttons, we got our planar gauge here. Alright, and we got some 1, 2, 3 blocks here to help us out. Okay, and then the other thing we have here is these space blocks here, which are kind of like gauge blocks. Okay, but they don't have quite the range of measurements or combinations that gauge blocks have, but they're nice for this kind of stuff where you're just locating to you know, a thou or a half thou or so. So Okay, so we got a couple of numbers here, and so let's do the vertical one first, okay? And the vertical number that I'm looking for is 3 inch 3625, okay? So there's 3 inch. We can do a 300, and then 0625, so that should be that dimension right there, okay? And then, oops, let me get my handy dandy little screwdriver there. So we've already set it in one axis there, okay? So I got the spacer under there, and that is locating that off of the surface plate, okay? You could also use a height gauge like this, and you could do it that way too. So there's lots of ways you can locate that, okay? So now what we want to do is we want to locate simultaneously. We want to locate off of this surface here. So what I need is I need something on this side. So let's slide this little monkey around, and then we'll put that up against there like that. And then what I'm going to do is I'm going to set, so this surface and this surface are parallel, and I can adjust that length, okay, to my other number. Let me double check my other number here. The other number is 3 inch 860, and I'm just going to set it with calipers here, but you can set it with a micrometer or gauge blocks. You could go crazy with that. 3 inch, what is it? Oh, 860. All right, 8761. Okay, double check my number. Okay, I like it. Okay, and you see that was pretty easy to set. Now I'm going to have to flip this over, I think, to get it in there. So let's see, let's do that. I think. Oh yeah, it looks pretty good. Actually, we can share. Oh, something doesn't look right. Oh, because it's supposed to be up there, Mr. Knothead. Okay. Let's see, how can I get that in there? We need that. We need that to that, huh? Can I go underneath? No, that's not going to work. All right. Well, let's do this here. Let's see what we need to do here. Oh, okay. That's all I need to do. Just need to not hog the space there, right? All right, now let's go up there like that. We'll butt that up real nice. So we're up against this reference surface, we're up against that reference surface, and I'm tucked in there. And now what I'll do is I'll just kind of push that down into the corner, and then I'm going to lock the screw down. Okay, and I'm bearing on that real nice. That feels pretty good too. Okay, all right, so let's snug that up. Now if you wanted this to be really, really precise, you can compare this to a stack of gauge blocks in both directions, and then the old guys used to tap these around and get them, you know, right down to the monkey's uncle. All right, so now we can take this stuff out. All right, let's pull that away, and now, so that is our bearing center, our bearing pocket center, and that's on there pretty good. You know, like I said, there's lots of ways you could do this, but I wanted to show this because this is kind of it's an old school way of doing this, and a lot of guys are really, really curious about the Toolmakers buttons. And this is a Brown & Sharp 758B set, and yes, there's an extra tapped hole in the center, so you only get 4 with a set. So okay. All right, so now we can go over and we can put this in the lathe, and we can indicate that, and we're right where we want to be, okay? Okay. Okie dokie. Let's get some heavy metal. comes to it. Or I'm pretty close anyway, so. Okay. Yep. Come on. Past it. Okay. Alright, let's get this thing pinched down a little bit. Okay. A little snuggage. And then give it a little. I want to hit my hit my nice center there. It's my A-bomb 79 knocker. Okay, now you can see the next problem here. You see that? We are way the heck out of balance. So we got to excuse me. We got to work on balancing that a little bit too. We don't want that lumping around. Okay, so that's not too bad. We're in indicating range there. So let's work on getting this counterbalanced here. So the bottom, that's the heavy side, right? So we need to put a little bit of weight up here to offset for that. And so I have some. I think I showed them in a meatloaf episode, but I have some little segments that we can put in here to put a little bit of weight on here and lock it down securely. So let's get started on that. I got some T-slot nuts, and then here's these are these little segments. I had these laser cut, and what we're going to do, let's just do it. Don't yap about it, just do it, right? Put the nut on ahead of time too. So this is a good example of why you need to counterbalance here. So let's get those kind of on there. So what we're going to do, we're just going to give it a try here. Okay, and you can see that that's helped quite a bit already. And then we can make these all nice and neat if we want. Actually, you know what? I'm not going to worry about it right now. I just want to get some weight on there and see how it behaves. So the idea is that you know, you put some weight on there, and then you keep spinning it just gently, and whenever it doesn't find it doesn't repeat, you know, then you know you're pretty close. So we're gonna slap some on here. Let's do that. Let's see how we're doing. All right. I still think it's off a little bit. So I think we're a little too heavy. That's what I think. Looking at this. Okay, so I'm going to take, I don't know. I'm just guessing here. Let's take one off. Let's see how it acts. Oops. The other one there. Now, you know, some other guys are kind of nervous about having these in open slots like this, and you know they're right. These could fling out, but you're going to tighten the snot out of these. You don't want these to come out, and also we're not going to be spinning at 1,000 RPM or something like that. All right, so let's give that a little go. Boy, hard to tell. I still think I'm just trying to feel if it's wanting to. I think it needs a little more actually, huh? So I think what I want to do is I'll take one of these long ones out and put two short ones back in, or two smaller ones back in. Anyway, I'm going to fiddle around with that, okay? You don't need to see the whole thing, right? But you get the general idea. Yes, we're going to tighten the shit out of these. Excuse my French there. And then we'll start indicating this little guy and get it lined up, and then we can start our boring operations. So, but it'll be exciting. It won't be boring. Getting close. Alright, let's go around and make sure they're all nice and tight, and then we'll dial in that last little bit. Not something you want whipping out of the old El Chucko, right? Alright, let's see here. What do we got? And there's a high right there. Alright, we're down around about 1 thou. Right there. Let's hit that one a little bit. Alright, that looks pretty good. We're all tighter than a monkey's uncle. Okay, so at this point, let me get this out of the way. Now you see, I had to come in there at an angle because the indicator was right up against the side there, and you know, I could do it like that, but that's not very fun. So, and then the initial run out was enough that the indicator wanted to come off of this little button. So what I did was I just put a little pointer up next to it so I could see what was going on, and got a little closer, then got it on the indicator, and went from there. So we're balanced up, we're spinning real nice, we're nice and tight. So I'm going to take my button off, and I'm going to pop this bar off, get a boring bar going, and we're going to go chip about here. I'll make some chips and open that hole up. This opens up to a little over 5 inches, so should be some non-boring boring. So okay, let's get this tool out of the way here. Stab myself on a boring bar. Okay, so we take that little guy out. Put him away in his little bed. Be the pits if you lost one of these screws, you know. You have to make one probably. The washers are lapped and everything, so anyway, that's what the set looks like. Okay, so now let's get Mr. Shifting Spanner here. Okay, get it in there. And then pop him loose, okay. Alright, I think we're ready for some boring. Ooh, let's make sure I'm not going to do any collaboration situation here. Oh yeah, okay, I gotta move some stuff around. The compound's going to come up real close to that, so I gotta move some stuff. Alright, so I think we're ready to do some boring here. Make sure we got a safe spindle speed here. Let's see, where are we here? We're at 200 RPM. Let's see what that looks like. That's pretty good. Alright, machine's not vibrating, so pretty happy. So I'm going to come up and I just want to, you know, there's chuck jaws behind this thing, so I got to be a little bit careful in that I don't over penetrate. and I've measured the thickness of these two plates together, so we should be fine. Check the feed rate here. Alright, let's try that. The first cut's always kind of interesting because you got some humpy bumps in there. Alright, let's try that. Let's give it a little bit. Neutral here. Alright, well, it looks like a cut to me. Alright, I'm going to take a little bit more in this next one. I don't know. Not much to talk about here. This is going to take a little while. You know, some guys may wonder why I didn't have this hole burned a little bit larger. And the reasoning there is, you know, the thinner these sections get as you're doing these flame processes, the more the piece distorts. So you're balancing, you know, web thickness versus the cutting thickness. And this isn't a really large piece here, right? So the whole thing is going to get hot when they're cutting it. So, you know, how big do you go? So better a little bit too small than a little bit too big and have this thing really wonky on the outside, or have a really crappy cut quality. So it's a little bit of a compromise there when you're doing that kind of stuff. So let's take another cut, get a little more aggressive on this one here. See what happens. See if this thing will put up with it. Yeah, that's pretty good. Finish passes here. Got about 18 thousandths more to go. We'll take a measurement after this pass and see where we are and do a finish cut. And then I like to verify on an OD mic too, to make sure. Okay, yeah. 8. Okay, so I got about 20 thousandths left on the bore. Let's go for it. Okay, punch it, Julio. Oh, come on, calm down. There we go. Of course, chatter on the last pass, right? Classic. And it looks like it's straightened up a little bit. Alright, according to my calculations, this should, the bearing should go right in there. Let's try it. Here's our bearing, 130 millimeter OD. I'm going to get it cocked. Come on. Well, it started. There we go. Alright. Alright. So this housing gets, later on it gets split, and then there's a clamp bolt here so that I can clamp the race. I didn't want to have to press these in during assembly. So anyway, that's that. We're going to do a facing cut on this. Then we'll probably separate the two from one another and continue on. So see if I can slide this out without getting it cocked. There we go. Okay. Looks good. Okay, curves matched.